this is Raji. We are learning how to express the concentration of a solution. We have done a number of problems related to percentage, strength, molarity as well as molality also. In this video, we will be discussing about mole fraction. How to express the concentration of a solution in terms of mole fraction, and we will be doing a number of problems related to that so that you will become perfect with the concept. So let's start with mole fraction. See this picture. When we are expressing the concentration of a solution in terms of mole fraction, the amount of the solute also and solvent also should be expressed in number of moles. To understand the idea better, I have taken little bit of alcohol in water. Let alcohol be the solute. Okay, see this one is alcohol and this one is water. In this solution, as you can see in the picture, I have taken 0.4 moles of alcohol, whereas the number of moles of water present will be 0.6 moles. If so, how to find out the mole fraction of alcohol in this solution? How to calculate it? Mole fraction will be equal to number of moles of one component divided by total number of moles present in the solution. So write it. What will be the mole fraction of alcohol? Mole fraction of alcohol will be equal to number of moles of alcohol. I will write it as Na divided by number of moles of alcohol plus number of moles of water. So in the denominator we have total number of moles present in the solution. Got it? Now what will be the number of moles of alcohol we have taken? That will be equal to 0.4 divided by the number of moles of alcohol plus number of moles of water. 0.4 plus 0.6. That will be equal to 0.4 only. So in the solution, the mole fraction of alcohol will be 0.4. If so, can you calculate the mole fraction of water in the solution? Write it. Mole fraction of water will be equal to number of moles of water divided by number of moles of alcohol plus number of moles of water. Right? So that will be equal to, what's the number of moles of water taken? That is 0.6 divided by total number of moles present in the solution. That is 0.4 plus 0.6. That will be equal to again 0.6. So by this way we can express the mole fraction of the solute also as well as the solvent also present in the solution. Okay. And also remember, there is no unit for mole fraction. Why? Because in the numerator also, denominator also, we are taking number of moles. So it will be cancelled. So there is no unit for mole fraction. Also, we will have to remember one more point. What will be the sum of the mole fraction of solute and solvent? It will be always equal to 1. Right? Mole fraction will be denoted by a Greek letter chi. We will write like this and we will pronounce it as chi. Okay. So how can you represent the mole fraction of alcohol? That will be chi A. And what is a mole fraction of water? That will be chi W. What will be the sum of chi A plus chi W? That will be always equal to 1. You will have to remember this point also. Got it? Yes. Now, to understand the concept of mole fraction better, we are going to do number of problems. See this question, it was asked in a 2005 ISC board paper. Okay, read and find out. Calculate the mole fraction of water in sodium hydroxide solution which has 80 gram of sodium hydroxide and 54 gram of water. So, we will have to calculate the mole fraction of water also, sodium hydroxide also. But they have not given the number of moles for that. Instead of that, they have given the mass of sodium hydroxide and water. If you know the mass of sodium hydroxide, is it possible to calculate the number of moles of sodium hydroxide? Yes, there is a shortcut method. number of moles will be equal to mass of sodium hydroxide divided by molar mass. In mole concept, we were discussing this one. Okay, yeah. Now, what is a mass of sodium hydroxide given? That will be equal to 80 gram. And what is a molar mass of sodium hydroxide? Sodium is 23, oxygen is 16, plus hydrogen is 1. So, if you are adding everything together, you will be getting 40 gram per mole. Okay, yeah. Gram cancel and you will be getting 2 moles. This will be the number of moles of sodium hydroxide. We got that. In the same way, is it possible to calculate the number of moles of water? Number of moles of water will be equal to given mass of water divided by molar mass. What's the given mass of water? That is 54 gram. 54 gram divided by molar mass of water. We know that it is 18 gram. So 18 gram per mole we can write. Yeah. Now gram cancel. If you are calculating this one, you will be getting the answer as 3 mole. Okay, that will be the number of moles of water. Now it is going to be easy. From that, how to calculate the mole fraction of sodium hydroxide? Chi sodium hydroxide we will write. That will be equal to number of moles of sodium hydroxide divided by number of moles of sodium hydroxide plus number of moles of water. Do that. That will be equal to 2 divided by 2 plus 3. That will be equal to 5. What's the answer? That will be equal to 0.4. Correct? Yeah. Now, how to calculate the mole fraction of water? That will be equal to number of moles of water divided by number of moles of water plus number of moles of sodium hydroxide. Okay. Yeah. What's the number of moles of water? That is 3 mole. 3 divided by 5. So that will be equal to 0.6. Now got the answer? Okay, yeah. It is not necessary to write the second step. Why? Because if you are getting the mole fraction of sodium hydroxide, how to get the mole fraction of water? Write it. Mole fraction of water will be equal to 1 minus mole fraction of sodium hydroxide. Because we were telling that mole fraction of all the components present in that solution will be equal to 1, right? Yeah. So in that way also you can calculate it. 1 minus chi NaOH, that will be equal to 0.4, which in turn will be equal to 0.6. This way also you can calculate it. It's so easy, right? Yes. Now see this question. These are some simple questions, but these were asked in board papers. Read and find out what's the sum of mole fractions of all the components in a 3-component system. We were already discussing about that. Whatever may be the number of components present in the system, the total sum of mole fractions of all the components will be equal to 1. If x1, x2 and x3 are the 3 components present in the solution, its sum will be equal to 1, you can write. Easy. Read the next one. Ratio of number of moles of the solute or solvent and total number of moles of the solution is called. Yeah, what's that? It is nothing but mole fraction, right? So answer is the 4th one. Got it? Now see this question. This is also a simple question related to the calculation of mole fraction, but it was asked in a ISC 2011 board paper. You can try this problem by yourself and find out the answer. If you would like to check whether your answer is correct or not, I will be sharing a link in the description box related to this video. You can click that link and find out the answer. Okay. Hope you might have understood the concept of mole fraction very well. We will be doing conversion problems in the next video. Till then, bye for this time. Thanks for watching.